Imagine for a moment that somewhere out in the vastness of space, a silent traveller is hurtling toward our planet. It is invisible to the naked eye, yet it carries the power to change life on Earth in an instant. Now imagine that scientists all over the world are watching, calculating, and preparing to ensure that this invisible threat never reaches us. Today, we are going to take a journey into the fascinating world of asteroids, the celestial rocks that wander through our solar system and occasionally cross paths with our home. Some are harmless, drifting silently in space, while others demand our attention because of the potential danger they pose. By the end of this speech, you will not only understand which asteroids we need to worry about and why, but you will also gain insight into how humanity is using science, technology, and collaboration to safeguard our future. This is a story of discovery, preparation, and the incredible power of knowledge, proof that even in the face of cosmic challenges, we have the tools to protect our world. Stay with me, because the secrets of the universe are about to unfold before your eyes, and what you learn today could change the way you see the sky forever. Near-Earth objects, commonly abbreviated as NEOs, are asteroids or comets that have orbits bringing them close to Earth's path around the Sun. While the majority of these objects are small and pose little threat, some can be large enough to cause significant damage if they were to collide with our planet. NEOs are particularly important to study because their proximity to Earth makes it possible for their trajectories to intersect with ours over time. Astronomers categorize them based on their size, orbit, and potential to approach Earth within certain distances, allowing scientists to prioritize which objects require close monitoring. These objects vary in size from a few meters across to several kilometers, and even a relatively small asteroid can release tremendous energy upon impact, equivalent to nuclear explosions, capable of devastating entire regions. Tracking NEOs involves calculating their speed, direction, and orbital patterns, often years in advance, to determine whether they might pose a risk. Understanding their composition and behavior is also crucial because it influences the strategies that might be used to divert or mitigate a potential impact. Some NEOs are fragments of larger bodies from the early solar system, while others may have been nudged from more distant orbits by gravitational interactions. By studying NEOs, scientists not only safeguard the planet, but also gain insight into the formation and evolution of our solar system, learning about materials that have existed since its earliest days and potentially identifying resources for future space exploration. Potentially hazardous asteroids, or PHAs, are a specific group of asteroids that pose a higher risk to Earth due to their size and proximity. To be classified as a PHA, an asteroid generally needs to be larger than 140 meters in diameter and have an orbit that brings it within 7.5 million kilometers of Earth. While this distance might seem vast, in cosmic terms it is close enough that gravitational interactions over time could alter the asteroid's path, potentially leading to a collision. The size of these asteroids is significant because larger objects carry far more kinetic energy, and an impact could cause regional devastation, tsunamis, or even global climate effects. Scientists carefully track PHAs using powerful telescopes, radar observations, and space missions, mapping their orbits and predicting future close approaches. The risk posed by PHAs is not constant. It changes as their orbits are influenced by the gravitational pull of planets, particularly Jupiter, which can nudge them onto paths that intersect with Earth. By identifying which asteroids qualify as potentially hazardous, astronomers prioritize monitoring and prepare for early warning systems. Public awareness and scientific transparency are also essential, as early detection allows governments and organizations to consider possible mitigation strategies. Studying PHAs not only helps in planetary defense but also offers valuable insight into the composition and structure of these ancient celestial bodies, revealing clues about the early solar system. Their size, trajectory, and potential consequences make them a critical focus for understanding and preventing potential future impacts on our planet. Throughout Earth's history, asteroid impacts have played a significant role in shaping the planet and influencing life. Some collisions were minor, leaving small craters and local effects, while others were catastrophic, altering ecosystems and even contributing to mass extinctions. One of the most famous examples is the Chicxulub impact, which occurred around 66 million years ago and is widely believed to have played a major role in the extinction of the dinosaurs. This asteroid, estimated to be around 10 kilometers in diameter, released an immense amount of energy upon collision, triggering massive wildfires, tsunamis, and a nuclear winter effect that dramatically changed the global climate. Historical impacts like this demonstrate that asteroid collisions are not just theoretical threats. They are real events that have occurred multiple times throughout Earth's geological history. Smaller impacts, though less catastrophic on a global scale, still serve as reminders of the dangers posed by space debris, as they can destroy property, disrupt human activity, and endanger lives. Studying these past events allows scientists to understand the potential consequences of future impacts and to model how different sizes and speeds of asteroids affect the environment. Crater analysis, fossil records, and geological evidence provide valuable data for predicting how similar collisions might unfold today. By examining historical impacts, humanity gains insight into the importance of monitoring near-Earth objects and developing strategies to protect the planet. This knowledge emphasizes that while asteroid impacts are rare, their consequences can be profound, making awareness and preparation essential for safeguarding life on Earth. Detecting and tracking asteroids is a critical part of protecting Earth from potential impacts, and it relies on a combination of advanced technology, careful observation, and international collaboration. Astronomers use powerful ground-based telescopes equipped with sensitive cameras to scan the night sky for moving objects, distinguishing asteroids from distant stars and galaxies. Once an asteroid is spotted, its position is measured over time to calculate its orbit and predict future movements. Radar technology is also employed for closer objects, bouncing signals off the asteroid to determine its distance, speed, size, and shape with high precision. Space agencies around the world maintain comprehensive databases that track known near-Earth objects, allowing scientists to identify which ones could pose a risk to our planet. In addition to observation, space missions have been launched to study asteroids directly, providing detailed information about their composition, structure, and trajectory. This data is vital because it helps scientists model how an asteroid might behave if it were to approach Earth, including how it might fragment, rotate, or respond to deflection efforts. Early detection is crucial because it provides time to prepare mitigation strategies, whether that involves evacuation planning, public warnings, or potential technological intervention. Collaborative efforts between nations ensure that information is shared rapidly, increasing the chances of preventing a catastrophic collision. Understanding how to detect and monitor asteroids not only protects Earth, but also advances scientific knowledge about these ancient celestial bodies, giving insight into the origins and dynamics of our solar system while keeping humanity informed and prepared for potential threats. Looking toward the future, scientists continue to identify asteroids that could pose a threat to Earth, in the coming decades, emphasizing the importance of vigilance and preparedness. Advances in telescope technology, satellite monitoring, and data analysis have allowed astronomers to predict close approaches with remarkable accuracy, providing years or even decades of warning for potential hazards. Some of these near-Earth objects are relatively small, capable of causing regional damage but are more important, while others are much larger and could have global consequences if an impact were to occur. Predicting future threats involves not only calculating current trajectories, but also accounting for gravitational influences from planets, the Sun, and other asteroids, which can subtly alter orbits over time. Public awareness is a key component of preparedness, ensuring that people understand the risks without fostering unnecessary panic. Governments and international organizations are developing protocols for communication, emergency response, and potential mitigation, so that decisions can be made quickly and effectively if a dangerous asteroid is detected. Ongoing research also focuses on improving early detection systems, testing deflection technologies, and simulating impact scenarios to understand potential consequences. Collaboration between nations is essential because an asteroid impact is a global concern, and sharing data, technology, and expertise increases the likelihood of a successful intervention. By studying upcoming asteroid threats, humanity can remain proactive rather than reactive, reducing the chances of surprise or disaster. This forward-looking approach highlights the responsibility of both scientists and policymakers to stay informed and prepared, ensuring that potential hazards from space are managed effectively while continuing to expand knowledge of our solar system. In conclusion, the study of asteroids and their potential impact on Earth reminds us of both the fragility and resilience of our planet. From understanding near-Earth objects and identifying potentially hazardous asteroids, to learning from past impacts, tracking their paths, and developing mitigation strategies, humanity has the knowledge and tools to protect itself from these cosmic threats. Staying vigilant about future asteroid approaches, investing in detection technologies, and fostering global collaboration ensures that we are prepared for whatever the universe may send our way. Science and awareness together empower us not only to safeguard our world, but also to explore and understand the mysteries of the cosmos, turning potential dangers into opportunities for learning and innovation.